3:20 AM on a Sunday morning. What better time to start tearing electrical stuff to bits? I am quite nocturnal. This is a very common lamp on eBay. It's a 126 LED lamp, and it's commonly sold as a grow lamp or hydroponic lamp, and has lots of blue. It's got about It's got about 36 blue LEDs and 90 red LEDs. So let's plug it in. This is supposed to be 15 watts. If you do a search on eBay for 126 grow lamp, you'll find these. But to be honest, not sure I'd recommend buying them, because here's the power meter. Says 15 watts. Looks nice enough with its pattern of red and blue LEDs. I'm not even sure if that's even showing. But draws 5.5 watts. So not quite the full 15 watts they're stating. In fact, it's about a third of it. But not to worry. So, I'm guessing, looking at the front, I'm guessing it might be a capacitive supply. I'm not 100% sure. Looking at the front, it seems to have a... I'll doodle it down. That's the best bit. So it's got 126 LEDs, and the front of it is divided into 6 sections, with the power cables coming onto the middle, and one of the power cables just goes straight up to a track, to a sort of bus bar track round outside, and the other one does a little bus bar round the inside. And in each of the sections there's 1, 2, 3, 4, 5, 6 blue LEDs in a row, and then the rest LEDs, there's 15, fill up the rest of the space in here. And that's just repeated around the whole thing. So that's, let's see, that's 15 red at about, say about 2 volts, and 6 blue at about 3 volts. Let's see, what's that going to be? That would be 30 volts and 18 volts. So say that's 48, say about 50 volts-ish across that. They look like fairly standard LEDs. I'm not sure they'll be being run at a huge current. 20 milliamps. So there's 6 sections at 20 milliamps. 120 milliamps. So let's tally that up. This is just guessing at the moment, really. So 120 milliamps, 0.12 times 50 volts. Yeah, maybe it's actually running a wee bit less current than 6 watts. But okay. So first test I really want to do here, if it is a capacitive dropper, is it going to have continuity from the front to the from the front wires here, which are fully exposed to touch, to the back? So let's check that by putting a wire on here and touching. Yeah, that's a diode junction. So yeah, pretty much a direct connection to the mains through this, so you wouldn't want to touch the front of this. It does pose a shock hazard. Well, let's plug it in and measure the voltage across that, and see how close it is to 50 volts. So keeping in mind the front of this is now live at mains voltage effectively, I shall use the meter to measure across where the cables come through. $49.5 volts. That was close enough. Okay, so it is about 50 volts across the front. technically speaking then I could work out the current, but actually, you know, I want to measure the current. Now, if I stick if I stick the current ammeter across one of the LEDs like normal, because they're wired as a series parallel array, I would expect the other lights to dip down in brightness, and a lot of the, because effectively then I'd be knocking the balance of the voltage off, I'd get a incorrect current reading. So I think it's time to open this up and poke about inside it and see what sort of circuitry there is inside. So it looks like it's just clipped in. And it's a switch mode power supply. Wasn't really expecting that. Little 8-pin chip, which does not visibly have a number on it. I don't know if it's just because it's been lacquered over. This is glued in this circuit board. There's no smoothing in the input. There's no. I can see the rectifier here, but no large smoothing capacitor. I can see this capacitor here, which is probably doing a bit of smoothing. But that does suggest that this is a buck regulator, and this is probably just a choke and not a transformer. And this is doing the smoothing of the DC side, although I did notice a wee bit of ripple there. Let's measure the current then. I thought that was going to be a capacitive dropper, but obviously that's not the case. So yeah, nice enough design. I'm not sure how warm that'll get. I'm not going to clap my hand over the front of it to find out. Now, if the front of the circuit board is live, then that makes it a bit dubious for hydroponic use, because if you're putting this above plants, and the plants grow up, they tend to grow towards the light, and all it's going to take is a shoot or something just touching any of these metal contacts. And because plants are actually fairly conductive, then the whole plant will, if it's sitting in a plastic tray, is going to come live. Which doesn't seem like a good idea. Anyway, let's measure the current here. I was stalling there for time because I just turned the soldering iron on. There we go. Let's put that out the way. So I'm just going to desolder one of the connections here. And I've got a little dinky meter that's already got crocodile clips on it, so I'll use this little trash meter, which is quite useful. So, do we take a guess then? We measured about 50 volts, and it's 5.5 watts. 5.5 watts divided by 50 volts equals 110 milliamps, roughly, if it was 100% efficient, which it wouldn't be. So let's put that there. Let's put that there, and let's plug it in. So hopefully I'll get a good connection there. Hopefully there's not a rogue track in the back that I shouldn't really be shorting onto. We'll soon find out and plug it in. Oh, there it goes. Oh, I'm not getting a good connection. 98.7, so about 100 milliamps. Okay, so pretty much as expected then. 100 milliamps at 50 volts, so the actual panel itself is actually putting out 5 watts of light. It doesn't seem that bright, but having said that, if it's using the traditional hydroponic style LEDs, there'll be the sort of 660 nanometer wavelength, which is a deeper red, and it does look quite a deep rich red. And that, I'll just tin these, that wavelength is supposedly better suited to hydroponic growth. I'm not sure if that's just because in the bad old days that was the most common high output red LED, was the 660 nanometer. These days it's more common to have 650, or even going to the rich neony red of 635 nanometer. So physically it's a nice enough lamp, but perhaps a wee bit disappointing that it's not isolated from the mains, particularly when there's a switching power supply in it. That would have been nice if it had just been, just fully isolated. But that would have made it a lot safer. But having said that, it's quite an interesting lamp. It's a nice colour. I like the fact that it creates a pattern. It's got that star of blue with the red. It's a nice visual effect. Just as I say, a shame that the thing's live at mains voltage in the front. Oh well.